Thank you, and thank you for coming. Just so you know, I was checking my email there. I'm setting my timer so I stay within the proper time. So I'm starting it right now. So this is the second, I believe, in our series of good news from the Gulf of Maine. And this is actually, tonight's installment is going to be about good news and from the Gulf of Maine and beyond. Okay, that's where the Newfoundland part comes in. So bear with us. We would like to talk primarily about New England and the Gulf of Maine, but really we thought that speaking about Newfoundland would give us some insights into how fisheries can respond to the same types of management that we're now practicing here in the Gulf of Maine. And one other thing, just that you can all take away from tonight, is how to properly say Newfoundland. Okay, so it's not Newfoundland or Newfoundland, it's Newfoundland. And the best way to remember that is understand Newfoundland. Okay, you have to put the emphasis on the land. All right, so I had to learn that. I'm not a Newfoundlander. I'm a Canadian, but I'm not a Newfoundlander, and that's one of the things that was drilled into me when I was living there. If you follow us on Facebook and you saw the ad for the talk, there's something in there about that I'll be talking about a plan that is a fisheries management plan that's producing encouraging results. Well, there's nothing new about what's going on in Newfoundland or what we're actually hoping to achieve right here. Really, as the title suggests, the long road to recovery, a lot of this has to do with things that are somewhat out of our control, and really the idea of, the wait, the longer you wait, the good things happen to all those who wait. This sort of applies here. And so just keep that in mind as I'm going forward. So if I can figure out how to advance here. So I assume that since you're here, you're interested in fisheries issues and you keep somewhat abreast of what's going on here in the Gulf of Maine, and that you probably have heard through various sources that we're not in such great shape now with Gulf of Maine cod. In fact, right now we're experiencing what some would call a crisis for Gulf of Maine cod. And here's just a smattering of some of the more visible headlines that have come out over the last number of months. But really, what this speaks to is that we got big problems with Gulf of Maine cod. And so I'm going to speak first to what happened in the Gulf of Maine. But before that, I want to get to why do we care about cod in the first place? And a lot of what I'm going to speak to in terms of some of the historical aspects of the cod fishery come from this book here called Cod, A Biography of a Fish That Changed the World. And this book was actually very influential on my own career. When I was doing my PhD at McGill, I was involved more in freshwater research. I was looking at the impacts of food webs on fish ecology, on mining pollution, on fish. I wasn't necessarily involved in marine fisheries, but I wanted to get involved in something bigger. And I read this book, and I was like, that's where I want to be working. And in fact, right after I read this book, I met a gentleman by the name of George Rose, who's a researcher in Newfoundland, and then I went off and did my postdoc with Rose. And some of his research will actually figure very prominently in my talk. So really, if you boil it all down, why do we care about cod? Well, cod is the reason that we're all here. If we go back 400 or 500 years, or even longer, 1,000 years, the reason that we know about this place, this continent, is really because of cod. And the best way to show this is, if I can get this pointer, if we look at the voyages of the Vikings on this side, right here, you can see, Eric the Red is credited with sailing to Iceland and Greenland, and you can see is sort of someone has put together some of the voyages here. And then the next generation, his son, Leif Erikson, actually pushed a little further along to Labrador and down to Newfoundland. We know that there are some Viking settlements in northern Newfoundland, Lonzo Meadows, and there's also, it's thought that some of these Vikings came around Nova Scotia and into the Gulf of Maine. And what's interesting is that if you look at the distribution of their voyages, it almost matches perfectly with the distribution of cod in the North Atlantic. And so a lot of people think that what fueled their voyages are the fact that they were cod fishing people, and that in order to have lasting nutrition along some of these grueling voyages, they were able to fish cod all along that sort of the coastal North Atlantic ecosystem. So that's very interesting. So really the cod might have brought the Vikings to North America. And then it wasn't long after the Vikings, we know that the Basques were fishing over in the New World, particularly up into the Gulf of St. Lawrence and into the St. Lawrence estuary. A while later, around 500 years ago, British merchants started fishing in the New World. And they didn't really, they weren't explorers per se, they were just looking to supply Europe with cod. And they had heard about these fishing routes from the Basques, and so they caught onto it and they started fishing in the New World. But again, it still wasn't exploration in the kind of way that we know it. And then it is rumored, of course, around the time of Columbus, that he caught wind of all this going on. And so it wasn't just a leap of faith for Columbus coming across the ocean. There were many, many more people before him that knew the routes, and he basically just followed them over. So really, I guess the moral of the story here is that fishermen can keep secrets, explorers can't. And so, coming closer to home, why we care about cod, and well, in general, we care about our fisheries. And so I think this plate exemplifies that. Maine is a fishing culture. We have a strong and robust fishing culture here in Maine. And it's not just Maine. It's pretty much most of New England. This is the sacred cod hanging in the State House in Massachusetts. And this commemorates 400 years of fishing in New England. And again, it's not just New England, but it's most of the North Atlantic nations that are involved in fishing. This is one of my favorite currencies. This is the Icelandic krona, and you can see the cod figures prominently in their currency. So this really, I think, shows how important fishing is to a lot of different cultures around the North Atlantic, particularly cod fishing. So what happened with cod? So now I'm going to get into a little bit of history, what went on in a relatively recent time frame in the Gulf of Maine, and sort of where we go from there. So this is just a chart showing the trends and landings of Gulf of Maine cod over the last 80 years or so. And you can see there's a lot of ups and downs. Some of this is due to fishing and availability, and some of it is just sort of natural fluctuations in the environment. We notice that there's this really high peak right here in landings, and then shortly after that, there's this drop-off. This is where we started to get concerned about codfish, and this is where we started to enact some stricter rules here in the Gulf of Maine, such as fishing limits, area closures, and gear limitations. We started to try to make fishing a little bit harder for the fishing fleet to try to conserve cod, because we were recognizing that this decline was a little too steep. And it seemed to be working. It seemed to start to turn around. And if we look at so the blue part is the landings. If we look at these lines, these are estimates of what is available out there, what is called the spawning stock biomass. And if you focus on the green line here, in 2008, or this is the 2008 assessment of Gulf of Maine cod, we can see that it was actually, we were doing pretty well. We had some rules put in place throughout the 90s, and then it looked like the spawning stock biomass was building up. And I remember when I got here in 2005, and a few years after that, I came from Newfoundland from a collapsed fishery to the Gulf of Maine, and I was thinking, this is great. There's nothing wrong with the Gulf of Maine cod fishery. It seems to be doing just fine. But then in 2012, the 2011 cod assessment came out, and there were some revisions. Basically, we looked back, we found out that there were some problems with the 2008 assessment, which I won't go into in too much detail, but a lot of it had to do with how we assigned weights to the discards that we put overboard. For instance, when fisheries discard fish, we count that into the assessment, but then we assume that they were the same size as the fish they were landing, when in fact a lot of the discards are much smaller. So that changes your overall view of the spawning stock. And also, there was a couple survey tows that were anonymous, maybe erroneously high, or they were counted too high in the assessment, and those have since been scaled back. And so when we redid the assessment looking back, this is what we found, that in actual fact, the spawning stock biomass was much lower than we thought over this period where we thought there was rebuilding going on. So we're like, okay, we have a problem. This was 2012 when we found this out, but we didn't act until 2013, because a lot of the times these things take time to go through councils and votes, etc., and to consider all the stakeholders' points of view. Then, in 2014, at the end of last year, we had an update to the assessment, and we found that the situation was even worse than we thought. The biomass was lower and continuing to get lower, and the landings were higher than we thought. So now we have this, again, this precipitous decline, and it probably has something to do with the fact that, first of all, we got the 2008 assessment wrong, and we set landings too high, or we set quotas too high, sorry, and so the fishery was fishing well within what the quotas were, but they were just too high because we set the quotas too high. That had its problems. Then we found out that then we waited too long. Maybe we waited a year too long to actually enact any kind of new rules. And you can see right here, this was the quota that was before we figured out that there was a problem. This is a quota after. This is a 78% reduction in cod quota, but this might have been a year too late. One could argue that we were already too late anyway. But in the end, what we end up with is these quotas set very low, the biomass is very low, and the landings are almost negligible. So we're pretty much in a no fishing scenario right now. There's just very little quota that's actually available for the fishery, very similar to what one in Newfoundland. So just in a nutshell then, what happened is we didn't even realize that we had a problem until 2012, and we didn't act until 2013. By this point, we've been setting quotas too high for too long. The stock has since crashed, and now we're also even beginning to realize that the productivity of the stock might be less because of temperature increases that also tend to reduce the productivity of the stock in this part of the world. Okay, so where do we go from here? So this is where I'm going to get to the Newfoundland part. So here we are in the Gulf of Maine, Portland right here. We're going to sail all the way up to Newfoundland. And when I talk about Newfoundland, it's not as if Newfoundland is just one big cod stock. There's sub-components of the stocks of cod around Newfoundland. So we have the south coast right here, which is different than the Gulf stocks right here. And what I'm going to talk about primarily is what is known as the northern cod stock. And I'm going to talk about the northern cod experience. This is the stocks that are off the northeast coast of Newfoundland all the way up into Labrador and extend down across the Grand Banks. So it's pretty much the northern Grand Banks right here. This was the large, iconic stock of Newfoundland. These other stocks are quite smaller. This is the stock that we hear about all the time that crashed in the early 90s. So just a little bit of history on this particular stock. Going back 500 years, we can look again at landings. And so there was this gradual increase in landings over time. Here we have modeled reconstructed biomass over this time frame. And what's interesting is that over this time frame, we knew that fishing was prosecuted primarily or almost exclusively by traditional sail power. So we had big sailing vessels going out, launching dories, hand lining the fish, not any bottom contact to speak of, and so really not a lot of impact on the fishery itself. So we see these the spawning stock not responding that much. It looks like something might have happened here, but what we know is that that was a cold period. It's called a little ice age, and we know that in Newfoundland, when it gets too cold, the cod don't produce as much, and the spawning stock biomass seems to have responded right there. So this type of fishing didn't seem to have an impact on spawning stock biomass. Then we get to the early 1900s. We see advances in terms of steam trawlers. Now we have the ability to drag nets over the seafloor. We could potentially have bigger impact on the stocks, but really not a huge impact at this point. It really wasn't until we saw the arrival of the distant water fleet where things got a little bit hairy. Okay, landings went through the roof. This is because these vessels were equipped with advanced technologies in terms of finding fish. They were able to stay at sea for very long times. They were able to freeze the fish. And this distant water fleet was able to come into within close proximity to nations like the U.S. and Canada and fish. And so we saw a massive increase in landings and then this drop off, kind of similar to what we saw in the Gulf of Maine in the 90s, but much bigger. And so this spawning stock biomass responded. In the early to mid 1970s, nations around the world started enacting 200-mile limits to declare exclusive economic zones around their territories, and Canada did this as well. And so this effectively stopped the distant water fleet or the foreign fleet from coming into Canadian waters. And so it was thought this is what's going to be needed to rebuild the stock. In fact, we saw somewhat of a rebuilding period shortly after that, an increase in landings. And this is because in the absence of the foreign fleet, we had a huge capitalization taking place in the domestic fleet. So all kinds of money was being pumped into building up the domestic fleet. That had a major impact on landings, and then the stock biomass crashed. So now we're in the collapse phase. We can actually look a little bit closer at what happened during this period. We know that through research cruises that the spawning stock was contracting. So when it was very abundant, cod were distributed very evenly throughout the entire stock region. But as they started getting less and less abundant, they started collapsing towards one location. You can see from research cruises, we could see this, especially at the very end of this time series. All the cod were in this one region. The fisheries started going towards that one region as well, but their catch per unit effort wasn't going down because they were able to continue to follow these cod into this one location and still fish very efficiently. So at the time when the stock was collapsing, the scientists in Canada were saying, hey, whoa, hold on, there's a problem here. But the fishermen were saying, look, there's still plenty of cod. Our catches are higher than ever. And so there was pressure at the level of the government to keep the fishery open, and that's what happened. And eventually the whole thing collapsed, and we had no fishery from 1993 on. We see something similar going on in the Gulf of Maine. If we look at the distribution of cod throughout the Gulf of Maine in the 70s, in the 80s, and the 90s, we actually see much more even distribution. There's no doubt there's more cod in the western Gulf of Maine than the rest of the Gulf of Maine, but there's still plenty of cod out here in these central regions and along the along the coast of Maine. Once we get to the 2000s, the 90s, and the 2000s, we see pretty much a disappearance of cod from the coast of Maine. Much less cod in the central Gulf of Maine here, especially now in the last 5 years, and the cod are really over here in the western Gulf of Maine. So this might be very similar to what has been called hyperaggregation in the Newfoundland fisheries. So the stock decreases in number, and the individuals contract towards what is considered optimal habitat. So where did we go from there? So here's another way of just showing the biomass of the cod over the last 30 years or so. So here we have the collapse, and the moratorium was declared in 1993, and then it was thought, okay, well, if we stop fishing, the fish will come back. And from the experience when the foreign fleet was removed from the Canadian fishery, we saw that there actually was a little bit of a recovery going on, but that was happening at higher biomass. So people did some models, and they figured out it would take very little time. This first model by Roughgarden and Smith suggested it would take very little time for the stock to rebuild, and this is what everyone was going on. Everyone was optimistic. Hey, we're out of business for 3-4 years, but everything's going to be back to normal by then. Well, we waited 3 to 4 years, 5-6 years, nothing happened. And then we started to realize, well, hey, when the stock's at this low of a level, the fish don't behave the same way than when it's at very high levels. The males and females don't form the spawning schools that they did in the past. They're not as efficient at finding each other, spawning and migrating and feeding. And so all of these disruptions in the normal behavior of a cod are termed compensatory mechanisms. And when you add those into the models of rebuilding, you see these downgrades in how long it's going to take. So the first whack at this suggested, hey, it's just going to take maybe a decade longer than we thought. Well, that didn't work. And then we got a little further along, and then we realized, okay, well, we just kept getting more and more pessimistic. And in reality, what we saw over this period was no rebuilding at all. Just cod were functioning like they were supposed to, the ones that were left. So clearly there's more to recovery than just imposing fishing restrictions. And so what might these other factors be? And I love this picture because I think it really puts into juxtaposition all the different forces that are going out there in the water. You know, we have the fishery acting on the fish stocks. We also have the seal staring down the fishery. The fishermen love to sight seals is one of the reasons why fish stocks don't recover, because they're out there eating the fish, which is a reasonable thing to bring up. But we just don't know. And so really, these things get thrown around all the time. Seals has always been a hot topic in Newfoundland. And in fact, in Newfoundland, you could do something about seals because there actually is a seal hunt. Continued fishing continues to get thrown around, although in Newfoundland, over that period, there really was very little ground fishing going on. Temperature has now become a big factor. We didn't really consider temperature to be a big factor through the 90s and into the early 2000s, but we're starting to realize now that it could have a major impact on stock rebuilding. And finally, what I'm going to delve into a little more in detail right now is food limitation. So, getting back to this question, what does it take for rebuilding? There's this idea that we need to return to more favorable food web or feeding conditions for cod in order for them to recover. And so the question then is, does food limitation exist in cod? And one of the problems is that there's this sentiment out there that cod will eat anything. And so when we started working on this, when people started working on this in the 90s and bringing this up, many other scientists would say, well, it's the ocean. There's plenty of food out in the ocean. If something goes away, cod will always find something to eat. So they just can't be limited in any way in terms of the food. And so this idea continued for a long time. It even showed up in reports from the Department of Fisheries and Oceans. And these are intelligent people putting these reports together, but writing sort of poetic things like, in fact, a cod will eat almost anything, including stones that can digest the sea anemones, hydrates, and other organisms growing in them. So this was a hurdle to get over. To address this question, we had to sort of do away with this idea that cod will eat anything and therefore will do fine on anything. We had to get past that. And so, based on some research that I'll just show you in the next slide, it was predicted that during the collapse phase, cod could not recover without the right food. And in particular, that food was predicted to be capelin. So we're going to talk a lot about capelin now. And capelin is this small, silvery, schooling fish, or a forage species, that are historically very important in ecosystems like Newfoundland, Iceland, in Norway, Barents Sea, etc. These northern boreal marine ecosystems. Very important. They're not important down here in the Gulf of Maine because it's too far south, but once you get up north of the Scotian Shelf and into Newfoundland, capelin historically have been very important. And so Dr. Rose, who was my postdoctoral advisor, had conducted some research prior to when I got to Newfoundland, and he published this paper, Capelin Are Good for Cod, and asked the rhetorical question, can the northern stock rebuild? Without from his point of view, they couldn't. And that's because of primarily this finding, where they found that whenever capelin were available to cod had higher liver indexes. So why is that important? Well, cod are a species that need to pack on energy reserves in order to carry out all of their life functions. So you think of life functions in terms of growth, reproduction, migration, overwintering. All of these things require fuel. And the way that cod cope with all of these needs is to fill the fuel tank. And the way they do that is they eat lots of oily, energy-dense species like capelin, and then all of that energy gets stored in their liver, and then they can go off and they can overwinter, where they can mature their gonads, where they can reproduce the next spring. If they don't get those energy reserves, then they're potentially not even going to survive the winter, but they're probably not going to reproduce and grow. So this was considered very important. Then we delved into it a little bit further. When I was there, we looked specifically at diet effects on growth and condition. So again, not just liver condition, but body condition and reproductive success. And we pretty much found the same thing, and we concluded that major rebuilding of cod stocks in Newfoundland will require a return to a system that supports high capelin availability to cod, which in turn should foster improved condition and spawning potential. So this was back in 2007. The research was actually in 2005, 2004, when there was no recovery going on at all. And this is what we argued would be required. So I'll show you how we came to that conclusion. So we went out and sampled around Newfoundland, and so as I mentioned, there's multiple stocks, and so we know that in the southern stock, which is also known as the 3PS stock, I think it's wrong. No, sorry. Start with the northern stock, Labrador, which is called also 2J. We knew that the cod were feeding primarily on shrimp. That was when we looked at their diets. It's pretty much all we found. When we go to the south coast, we know that there was multiple things in the diet, but capelin figured very prominently. So we figured that if we could compare the diets between these different regions, we could look at things like growth, like reproduction, and condition. And so this is just verifying the diet. As you go from the south where there's capelin to the north where there's shrimp, we found this gray area right here is shrimp feeding, and this white area right here is capelin. These are all different sizes of cod in June and January. And we can see that up north it's all shrimp, down here it's mostly capelin. What's interesting is, as I said, cod will feed on capelin and they'll store that energy and then they'll go over winter. And they don't necessarily feed during that overwintering period. So if you look at the south coast where they're feeding a lot on capelin, you compare June to January, there's a lot more feeding going on in June than there is in January. When you get up to this shrimp area right here, there's still a lot of shrimp feeding going on in January just because they haven't accumulated those energy reserves. They still have to get out there and feed, so they're not in a position where they can just overwinter and mature their gonads to reproduce. This is a scary graph. I apologize for it in advance, but there's some neat findings in here. So what we did is we didn't just look at diet. We looked at a chemical or isotopic tracer of diet. So you can actually see what a cod ate over the last few months, as opposed to what it just ate that particular day. So that's always been a criticism of diet studies. Well, how do you know it didn't eat something different a few months ago? With this approach, known as stable isotope approach, we can take a fish, we can measure its stable carbon isotopic signature. So that's not important to remember that. Just know that there's a chemical means of figuring out what diet was. And we can say whether it fed mostly on something like capelin or mostly on something like shrimp. If the signatures are down here, more negative or lower, it's more capelin-like. If it's up here, it's more shrimp-like. So if you just focus on this figure right here, this is the southern population, and this is the northern population. So over this size range right here, these are all the length bins, we saw that in the south coast, they were feeding heavily on capelin, and then they move on when they get hit into other big things. But they weren't doing that in the two northern populations. When we look then at their condition, this is liver, over that same size range, the capelin feeding population carried that liver condition through all of this size, which is where they start to reproduce. So it's very important, because that's when they normally would start to mature. They had access to that important energy source. The fish that didn't have the access lost a lot of condition. And then this is body condition. This is how relatively fat you are compared to how long you are. And again, in the capelin feeding population, they were doing much better. And so I'll skip over this next figure. It shows basically the same thing. But what was important about that is that when we compared reproductive output, we saw differences. And at the time I was working with a reproductive physiologist, and we would go sample in this overwintering population, and he would be able to dissect a cod, and he would be able to say in January, during this overwintering phase, whether that cod was going to continue with the maturation process or whether it was going to abort the process. And cod will abort the process if they deem that they don't have enough energy stored to make it through the rest of the winter and reproduce. And so we have what are called sort of non-spawners and spawners. When we looked at their history of feeding, what we found is that the ones that were going to go through with spawning had a history of feeding on capelin, and the ones that were aborting the spawning had a history of feeding on shrimp. And so we thought this is a real smoking gun here, that diet is very important, not only to liver condition and body condition and growth, but also with reproductive success. So really, without capelin, cod can't store energy, they can't grow, and they can't reproduce. And we didn't do this, but another group of researchers also showed that they may also suffer increased mortality if their condition gets low enough. There's sort of this critical value below which, if their condition gets too low, they might actually die at greater numbers. So the best way to remember this is, if you think of cod eating forage fish like capelin, it's like eating a stick of butter. We don't like to eat sticks of butter because we don't want to get fat, but cod very much want to get fat over this seasonal cycle. And cod feeding on shrimp is like eating broccoli. They don't want to eat broccoli. We do. We don't want to get fat, so we eat lots of broccoli. But they're the complete opposite of us. They're trying to fatten up every season. to make it through the winter and reproduce. So the bottom line then is that northern cod cannot recover without capelin. So the question always arises, and sometimes I give this talk and I don't have enough time to get into, well, what happened to the capelin? And that question invariably pops up. So I'm going to go into some detail what happened with the capelin here. So if we look at the trends in capelin abundance over the last 30 years, we see this major decline in capelin around the late 80s and early 90s, which is exactly around the same time that we saw the decline in the cod fishery. So that was interesting. And really what precipitated this is a cold water event around that same time. So we had this intrusion of Arctic water over the northern Grand Banks, over that northern shelf region, and it was just inhospitable for capelin. Capelin are a cold water species, but they're not an Arctic species. And we actually saw some Arctic species come down over the shelf. Arctic cod, for example, don't normally live on the northern Grand Banks, but they did during that short period of time. And so capelin were pushed further south, and in some cases they were pushed around the south of Newfoundland and onto the Scotian Shelf in Nova Scotia. And so that happened, we know, and then the cold water retreated, it got back to normal, but the capelin didn't come back. And so now we're left scratching our head, well, why don't they come back? And in the meantime, what we saw was this major buildup in snow crab and northern shrimp. We hear a lot about northern shrimp here in the Gulf of Maine as well, but northern shrimp in Newfoundland is huge now, or it was. I'll get into some trends in there as well. But we saw this buildup of these crustacean species, and then the capelin just flatlined, just like the cod did. It just didn't come back. And so now we're left wondering, well, is this some kind of interaction going on, or are shrimp potentially somehow competing with capelin, or is there some kind of more fundamental ecosystem change at play here that maybe just makes the system more hospitable for crustaceans and less hospitable for capelin? We don't really know the answer to that, but we see a lot of these things happen in marine systems around the world, and they're called regime shifts. Sometimes the regime is just good for one species and not so good for the other. And so this looks a lot like a regime shift, where we've gone from a pelagic forage fish ecosystem to a crustacean-dominated ecosystem in a very short period of time. So if we go a little bit further, not so long ago, about 7 years ago, there was this blip in capelin. So we had this flat line, and then what looked like this little hint of a recovery. And this doesn't look like much, but if we blow it up, you can see this would be the flat line right here. And then we saw these years where, hey, it looks like it's getting better. And this was really encouraging. And if you actually saw what was going on in the beaches, it was even more encouraging. So when I lived in Newfoundland from 2002 to 2005, right in this period right here, I never saw this. And I'd heard about this all the time. People would say, traditionally, everyone would go down to the beaches and scoop up capelin as they came into the beaches to spawn. That's typically what capelin do. And it sounds like something really exciting and fun to do. But I never got to see it, and I just assumed it was a thing of the past. It wasn't ever going to happen again, and we're just all going to move on with our lives. Well, in 2007, 2008, 2009, this started happening again, and people on my Facebook feed were sending me pictures, and this is actually one of my Facebook friends who sent me this picture, and it seemed to be really exciting, but then it dropped off again. Like, oh man, that was short-lived, but maybe it'll come back. And so we held on to hope, and sure enough it did. This drop-off was very short-lived, and it looked like now we're in this full-scale recovery phase. It's nowhere near up here, but we're on the right track. And what's even more encouraging about this is that, fishermen are now starting to see fish in the inshore in their tracks. There's a small capelin fishery in the inshore. Capelin are getting larger and fatter. So during the crash phase here, they were really in poor condition, the same way that I've talked about cod being in poor condition. Their distribution patterns are more normal, so they're starting to take on migrations that we knew that they carried out over, long time periods. Historically, they would make these huge migrations around the whole shelf, 1,000 kilometers. We didn't see them doing that over the collapse phase, but now they're starting to move like that again. Their depth distribution starts to look more normal. Over this period right here, capelin, which are a midwater species or a pelagic species, went right to the bottom. And we couldn't really figure out why. Why are they on the bottom? Well, one of the reasons might be because, hey, in low abundance, you no longer have the safety of a school so therefore you go to the bottom. That's one possibility. The other possibility is that, as I mentioned, the regime might have shifted, the production regime might have shifted, so that most of that production was now on the bottom favoring the shrimp and the crabs, and maybe the capelin had to get down lower in the water column to capitalize on that as well. We don't really know the answer to that, but there's lots of questions. But at any rate, capelin now seem to be going back up into the water column, which is exactly where they should be for marine predators like cod, whales, and seabirds. And also, importantly, there's a higher proportion of older spawners. Capelin should spawn around 3 years old. They're not a long-lived species, but during the crash phase, they were spawning at 2 years old. And that's much too young because they're not big enough yet, so they don't have enough of an impact on future reproduction when they're that small. They need to wait a year to get big enough to be impactful. And so really what it looks like is going on is that the ecosystem is changing. So we see the capelin are starting to make this increase, and things are going back to their normal behavior. And as I mentioned, over this time period, shrimp and crab were doing really well. Well, now they're on the way down. So if you look at crab, there's been this steady decline since the late 90s, and this more recent decline, which people are very concerned about because the projections are it will just continue to decline. There's this very marked decline right here in this shrimp population, as well as this. Pretty much all of them, the shrimp are going down over the last 7 or 8 years or so. And so it looks like, again, this might be a regime shift. We might be going back to that pelagic-dominated system. And what's driving this? Well, we think it's temperature. If you look at, this is just crab right now. If you look at the temperature trend, the area where crabs live in Newfoundland, the northern shelf, is getting warmer. The amount of available habitat is getting less. So the available habitat is defined as habitat that's less than 1 degree Celsius. Snow crabs are a very cold water species. So that available habitat's going down, and then the crab are also going down. This is predicted to continue. This is just the same graph. You can see the blue points, and the blue line right here is up to the present, and then this is projection into the future. And so the Newfoundland shelf is projected to continue to warm over the next decades. And so this will just be continuing to be bad for shellfish like shrimp and crab, and possibly to the benefit of finfish like capelin, cod, haddock, etc. So what was the northern cod response to all of this? And so this is basically the punchline. This is why we're all here. We're interested in cod and fisheries recoveries, and this is it. This to me is like, wow. I spent my whole time in Newfoundland right in this period right here. There was no hope. We'd already gone through, more than 10 years, and we just looked like there was 10 more years of nothing. And then all of a sudden, 7 years ago, we saw this uptick, and it just continues to go up. When we look at this number right here, this is called BLIM. This is a reference point to which managers are striving to rebuild the population. And what they've done is they've taken the average biomass, spawning stock biomass, over the 1980s, and they've made that equal 1. And now we look at the proportion of the stock in relation to that number. And so the average 80s is equal to 1, and right now we're at 32% of that line called BLIM. And so to me that's astounding, because over this whole period right here, we were at about 1 or less percent of BLIM. It was bleak. And now we just continually keep going up, and it looks like, hey, we're maybe a third of the way there, and it just continues to increase in pace. What's interesting is that if we compare that graph to the capelin trend, they almost map perfectly onto each other. You saw the drop in capelin around the exact same time that cod crashed. You saw the exact same length of lag period in the recovery, and then we see the recovery happening around the same time that we saw the first initial blip and then the more substantial recovery. And so it's not just fishing. I should go back to the history of fishing in Newfoundland, that around that collapse phase. We talked about fishing sort of driving the fish into that one location. It was also the fact that capelin were declining and they were moving south because of the cold water. So a lot of it had to do with changes in the environment as well as fishing. And so those two things together, heaped on top of one another, really did the cod in around the late 80s, early 90s. But now it seems like a reversal of all that. Removal of fishing and addition of capelin seems to be turning the system around. I really think this is interesting because, again, I talked about this little blip right here where, again, it doesn't look big on this scale, but it potentially had a very large effect on the cod when they were at low biomass. And so around the time that we start to see capelin on beaches, people were getting very excited about those capelin. People were also starting to see capelin in the diet of cod. And those cod out there were starving out on the northern Grand Banks. They were small and skinny and probably starving. As soon as capelin came along, a lot of them just doubled their size overnight by just eating capelin. It's been shown in the lab that if you bring those fish from the offshore where they're in this starvation state and you feed them capelin, they grow really fast. They pack on the pounds, and it's almost an instantaneous reaction. So this right here was what we call a biomass recovery. It wasn't we weren't adding any fish. We were just fattening up the fish that were already there. This right here is recruitment recovery. So those fish that we fattened up potentially got to a point where they were healthy enough to start reproducing again, and now we're seeing the lag effect of those what we call recruits entering into the fishery, entering into the spawning stock biomass. And typically that takes about 4 or 5 years in Newfoundland. So there's also some other interesting indicators of a return to normal, particularly migration behavior, spawning activity, and feeding. So if we go back in time before the collapse and we look at the behavior of cod when they were very abundant, they had some really neat migration habits. They would migrate over 1,000 kilometers from the inshore in Newfoundland to the offshore, the edge of the continental shelf, and back again. They would just sort of follow this clockwise pattern. And really what they were doing is they were following the capelin. They were doing the exact same thing. And so when the cod collapsed, they stopped doing all these migrations. The migrations were completely arrested and stopped, and cod they stayed in place. We had a few remnant populations there was one right here in a place called a fjord called Smith Sound, and then there was an area off near the shelf break called Bonavista Vista Quarter, and the cod just stayed put. They didn't migrate at all. And that persisted over the period of the recovery phase. Well, more recently, around 2012, Rose et al. Tagged a cod with a data storage tag, and they followed its migration from the offshore to the inshore. And this was the first cod that they saw do this since the crash of the cod. And so this was very encouraging. This is why, the amazing journey of cod 17 is just one fish, but hey, look, it's starting again. And now we know that through further study that this is now becoming the norm. But that was the first example of, hey, this inshore migration is rebooted. Going back before the crash, we also know that cod in large density used to form these spawning aggregations, and once they got to the right numbers, they would form these spawning columns. And this is a really neat behavior where the cod will rise up off the bottom, and it'll almost sort of swim in a vortex, and it's thought that when the males and females swim in this vortex, it enhances the chance that the eggs are going to be fertilized, but it also puts the eggs up into the water column to make them dispersed out over the shelf, because this is the population that relies heavily on eggs dispersing over large distances. So this is a mechanism that they use, that they need in order to produce at high numbers. We didn't see any of this during the collapse phase, and this is something that we saw this year. Actually, we didn't. I wasn't there, but they saw. And this is very encouraging to see these spawning columns taking place again. And then finally, as I said, cod will follow capelin when capelin are around. The capelin will migrate, and the cod will migrate with them, and the cod will feed on the capelin all the way around, kind of like the Vikings were feeding on the cod all the way around the North Atlantic. And so we didn't see any of these shoals of capelin throughout any of the collapse phase. What this is an echogram, or the readout from a fish finder, showing the seafloor and then the water column. And this is about 350 or 320 meters deep, and this is about a mile long. And you can see that this is a very big school of fish. It's a continuous school of capelin. And then all these little specks right here are individual codfish. They're swimming up from below the shoal of capelin, and they're attacking those capelin. And along the way, they're getting fatter, they're getting bigger, and they're likely going to go and hang out somewhere in the winter and mature. And that's the type of behavior and ecosystem interactions that we're interested in for codfish. So if we boil that all down, this is into one figure. This is what it all looks like. We've had some warming going on over the Newfoundland shelf. This has led to some ecosystem changes. We've sort of reshuffled the deck. Crabs and shrimp are on the decline. Capelins on the rise. This increase in capelin seems to be fueling recovery of the cod. There's also a potential for temperature to act directly on cod. Increased temperature in a place like Newfoundland can make the cod grow faster. It can also increase the chances that their eggs and larvae will survive. So we get higher recruitment. But this isn't necessarily true for everywhere. And this author, Ken Drinkwater, did a study back in 2005 where he compared the performance of cod stocks throughout the North Atlantic. And what he found was that under different warming scenarios, these different cod stocks will have different responses to the warming. So Newfoundland, pretty much all the Canadian stocks, you can see these green circles right here. This is Newfoundland, and here we are in the Gulf of Maine. These green stocks are the Canadian stocks. The green means that they're all going to, if the water warms, those stocks are going to increase in number of biomass. The red means there's going to be a decrease, yellow means no change, and black means the stock no longer exists. So here we can see with a 2-degree increase, this was a prediction back in 2005, Georges Bank cod will decrease, Gulf of Maine cod won't change, Newfoundland will increase. Here over in the Celtic and Irish Sea, we'll see the disappearance of cod. We'll see some major declines in the North Sea, and then the only other places where we'll see increases are cod that are pretty much at the center or northern end of their thermal range. Okay, so the reason that things are getting bad for cod down here is because it's already warm. They can't weather it being any warmer than it already is. Whereas in Newfoundland, it's in the mid-range of temperature. So if you boost that temperature up, growth rate increases, and the cod can still stand to live within that temperature range. Okay, so I mentioned seals. So what about seals? And this always comes up as well. And at first I never really thought that seals had much of an impact because I had some colleagues who were working on the diet, and they weren't necessarily always targeting the cod in the way that we hear anecdotes that they do. And in fact, that early phase of recovery, not the most recent one, looked like it was taking place at the same time that seal abundance was very high. So I was like, well, seals they're important, but they're not any more important than any other predator out there in the sea. And cod have to deal with a lot of predators. Well, I think I've revised that thinking a little bit with the most recent data. Here again is the spawning stock trend for the cod, where we see the recovery. And here are seal numbers over the same time period. And we can see from the early 1980s, relatively almost to present, 2012, we see this huge increase in harp seals, which is that's the species for Newfoundland. That's the numerous species. It's a 4-fold increase in seal numbers and population size. This purple line right here is annual catch of seals. So it looks like that catch tracked the rise in the seal population for a time being, and then it dropped off. Right? So that could be due to a number of different things, including management. But if we look at seal pup production rates, pup production has fallen off drastically over around the same time that shrimp and crab are going down, that capelin are going up. And so this is interesting. So what's causing this is really this warming trend is now affecting the extent of the sea ice over the Labrador and Labrador Sea and northern Newfoundland. And harp seals need ice in order to pup. If they don't have the ice, then their pup production goes way down. But not only that, their distribution follows the ice. So now the seals are producing less pups. The population is still high. It's still 7 million individuals, which is extremely high. But that population has been shifted way north, and they're not producing as many pups. And they might be out of the range of where this cod recovery is taking place. So I think there is a real possibility that there's some kind of interaction going on here, what we would call a top-down interaction, where the seals are eating down the cod. So something to think about. And so now we can say, well, maybe the seals have as much of an impact as the capelin, and I think some further studies might reveal more on that. And the seals also might just be responding to the temperature. So this might all just be correlational. Seal pup production might be going down just because of temperature and sea ice extent, and then temperature is driving this change in the ecosystem and the increase in capelin, and they might not have anything to do with each other. So again, I think the jury's out on that, but there's some interesting trends. And then finally, we can't forget that there was management involved in all of this. The cod might not have come back, or probably wouldn't have come back if we didn't have this moratorium in place. And so this is getting back to what I was saying, and when I first started out, I said, well, it's this management plan that's producing encouraging results. Well, it just took 20, 25 years. We put the moratorium in place. We needed to let the ecosystem play out over that time frame. With the moratorium in place, I think we're now seeing the fruits of that long-term strategy. And the real challenge now for Newfoundland is when to open the fishery. We're starting to see all these fish. People are getting very excited. You know, the few small fisheries that are taking place up there are seeing lots of cod. And now people are sort of rattling in cages and saying, hey, can we start fishing again? And I think it'll be a real challenge to figure out when to fish. Interestingly, Newfoundland fisheries, as our other fisheries around the world, are seeking MSC certification. That's Marine Stewardship Council certification for sale of fish, primarily in Europe, but also around the world. And in order to get that MSC certification, they have to hit that B limb. So we're only 32% of the way there. But once they get to that B limb and they can show a whole range of other management capabilities, they will probably get that MSC certification. And so that means that basically if that was your goal, you would have to hold off, but that's not necessarily everyone's goal. And then finally, I'm close to the end. Yeah, I only got 2 more slides. You know, as is the case with any recovery, there's going to be winners and losers. And so I'm not an economist, but I threw together this figure last night, just looking at some Department of Fisheries and Oceans landings data in terms of dollar value. If you look at shrimp and crab, they're still very valuable. Even though they're crashing, we're still getting a lot of value out of those fisheries, and we're not fishing the recovery in cod. So these together are around $500–600 million annually to the Newfoundland economy. So the Newfoundland fishery is actually more valuable now than it ever has been. And if the cod and if the shrimp and crab were to crash and we were to rely only on cod, we could never recoup the value of that fishery. So in that scenario, the Newfoundland fishery would be less valuable than it has been over the last 10 or 15 years or so. So that's something to think about. As fisheries ecologists, it's always exciting to go back to a state that we deem as more natural, but in reality, it might not be the most economically viable state. And this is very similar to what's gone on in the Gulf of Maine. We've seen this huge increase in lobster landings and value over the last 30 years or so. And this is corresponded to a huge decline in codfish, especially in the nearshore Maine area, where cod and lobsters are going to interact the most. And we also know that cod and lobsters probably have more interactions than do crabs and shrimp and cod up in Newfoundland. We've studied this heavily. We know that cod can feed lobsters. And so if cod came back, this might fall off again. And then you're going from, if you had a fully rebuilt cod population in the Gulf of Maine, the value to the Maine fishery would be $28 million versus currently, in 2014, the value of the lobster fishery is $457 million. So you wouldn't even get to within an order of magnitude of what the current fishery is actually providing. So again, recoveries potentially have costs in terms of real dollar values. So this is my last slide. So just to sum that up and then bring this back to the Gulf of Maine, the Gulf of Maine stock has been overfished, but we now have major cuts in place, cuts to quotas. So again, now we're kind of like starting out that moratorium that Newfoundland went through. And the question is, how long will it take? We just don't know. Part of it is because we don't know whether or not Gulf of Maine cod are food limited, for instance. There was a real clear-cut case for food limitation in Newfoundland, but the case is less clear in the Gulf of Maine. When I was saying that, there's this idea of food limitation in the ocean, and there's too many things out in the ocean for something like a cod to be limited. Well, the Gulf of Maine is a little closer to that idea, that there's just more options in the Gulf of Maine. However, we're interested in this river herring plate, and if current efforts to restore alewife to Maine rivers and also other northeast rivers are successful, we might actually see a resurgence of cod in the coastal areas. Temperature is a huge factor in the Gulf of Maine, but as opposed to playing a positive role like it did seems to be playing in Newfoundland for cod, it's likely to have a negative impact on Gulf of Maine cod. And that's, again, because we're at the southern end of the distribution, and temperature's rising really fast. And in fact, over this time period, over the last 10 years or so, the Gulf of Maine is warming faster than 99% of the world's oceans. So this is a real something to keep our eyes on. So with this current temperature rise and projected temperature rise, the Gulf of Maine may not be hospitable for cod. So this is all within the theme of this lecture series, I hope. But it's just that's the bare truth right there. And then again, if cod do recover, they may displace lobster, which would be an economic loss, since cod could never be the dollar value of lobsters. But it would be a potential ecological boom. So thank you for your attention. And one last tip, if you're out there fishing and you want to make your catch look really big, put it next to a really small person.